What if the most efficient vehicle you'll drive in your lifetime doesn't need a plug most days, sips energy at a quarter of a typical EV, and travels up to 1,000 miles on a charge because the sun quietly tops it off while you live your life? What if the shape that makes that possible isn't a box on wheels, but something closer to a bird slicing through the air? Keep that picture in your mind, because by the end of this story, you'll know exactly why this machine exists, how it works, and why it might change what we expect from transportation. Let's start with a bold claim. This EV is designed to produce the lowest aerodynamic drag of any production-bound car ever tested, and nearly twice the efficiency of a Model 3. Big words. So here's how those words become physics you can feel. Most vehicles burn their energy fighting the wind. At highway speeds, 60 to 70% of the energy goes to pushing air out of the way. A boxy car shoves a high-pressure wall at its nose and drags a low-pressure wake behind it, like a parachute you can't cut loose. This EV attacks that problem at the source. Up front, the nose is razor clean, an aggressive, sharp entry that lets the air split and stay attached. Along the belly, the body narrows and then swells into a gentle hump toward the tail. That shape speeds up the air under the vehicle, creating a low-pressure channel that pulls high-pressure air from the nose toward the back, equalizing forces that normally waste energy. The result? The main body's drag is effectively neutralized, not minimized. Neutralized. That's the kind of phrasing you only use when you can back it with numbers. You don't sculpt something like this by hand and guess. Thousands of computational fluid dynamics iterations later, the kind of supercomputer-scale simulations you couldn't dream of a decade ago, the surface converges on a solution the math keeps demanding. Nature's answer looks more like a fish or a Swift than a sedan. And here's the kicker. You can't outscience this shape later. If you fast forward 30 years, the laws of fluid dynamics don't change. Once you land on the minimum drag body for this mission, it stays the minimum drag body. Underneath that slippery shell is a powertrain that refuses to waste motion. There's no long drive shaft, no U-joints, no transaxle churning away. The motors live inside the wheels, turning directly where rubber meets road. By erasing those mechanical losses, the drivetrain itself gains about 20% efficiency over typical setups. Combine that with a featherweight composite chassis and a body that slices air instead of punching it, and suddenly your energy use drops to roughly a quarter of what the average EV consumes. The practical translation? Imagine parking with a nearly empty battery, plugging into an ordinary household outlet, the same kind of outlet you'd use for a phone, and waking up with nearly 200 miles back in the pack by morning. No special equipment, no exotic infrastructure, just physics, working while you sleep. Now add sunlight to the equation. Solar integrated across the body continuously trickle charges the battery anytime the vehicle is in the sun. Think of it as an ever-present topping-off effect, designed to keep the pack comfortably full whenever possible. In a sunny coastal climate, you can expect about 40 miles of solar charging per day, roughly 11,000 miles of free annual driving. In cloudier or northern cities, the yearly figure is lower, but still meaningful, on the order of thousands of no-plug miles. For commutes and errands, this means many owners simply don't charge. The car takes care of itself. Battery options scale with ambition. A roughly 32 kWh pack for about 400 miles, then larger 60 and 100 kWh options that reach toward a 4-digit figure, up to 1,000 miles when paired with the car's extraordinary frugality. That frugality shows up in the EV metrics too. Energy consumption targets hover around 100 watt-hours per mile, which translates to an eye-opening 350 plus mpg. Use less energy, carry less battery, spend less money, and extract more freedom. That's the logic stacking up in your favor. Open the body, and the practicality doesn't vanish. It multiplies. The footprint is as long as a Prius and as wide as a large premium sedan. But the cargo area is shockingly useful. Fold the seats, and you'll find roughly 7 feet from the back of the seats to the tail. That's bikes fit flat space. That's camp and sleep comfortably space. The rear hatch design extends to ease loading, with a low floor that welcomes gear instead of fighting it. There are thoughtful touches planned for people and pets, access steps, partitions, and simple, durable surfaces that treat daily life as a first-class use case, not an afterthought. Inside, you'll notice a minimalist ethos that serves efficiency and experience at once. Controls consolidate onto the central display and steering interface, reducing the spider web of wiring that normally threads through a modern vehicle. Distributed I/O controllers, small boards placed strategically in the doors, dash, and rear, let a lean harness do more with less. A typical EV's harness might weigh 90 pounds. Here, it's around 30. Fewer connectors, fewer potential failure points, less weight. Every ounce saved is another ounce the motors don't have to move. The steering interface adopts a yoke, so a wide rear vision display can live directly in your line of sight. Instead of darting eyes to mirrors, you keep your attention forward while still tracking what's behind and beside you. It's a simple idea executed to support situational awareness, the kind that calms the mind when you're threading traffic or merging at speed. As for charging on the go, the design aims for a 50 kWh DC fast charge capability. With such a small energy budget per mile, that rate is more than enough. Top-ups take tens of minutes, not hours, and in many real-world stops, you'd be moving on well before the battery begs for it. The charge port stays delightfully simple. A clean magnetic door that opens by hand. No motorized ceremony, just utility. Efficiency is pointless if safety doesn't keep pace. Here, the philosophy follows high-performance aviation and motorsport more than mass-market car making. The passenger cell is a carbon fiber-rich composite safety shell that arches over and around the occupants, designed to absorb and redirect energy before it ever reaches the people inside. Roof crush performance has tested at the top of the passenger car spectrum, and the nose incorporates about 750 millimeters of crushable structure, well beyond the common 5-star benchmark requirement of 650 millimeters. Side impact protection focuses on the hip point, the area most vulnerable in T-bone crashes, using boxed-out structural reinforcement to keep intrusion at bay. The objective isn't just to pass tests, it's to set a standard that keeps the people you love safer than they'd be in many heavier vehicles. There's another unexpected upside. The regulatory category classifies this as an autocycle motorcycle for homologation purposes, which means the path to legal road use is already cleared. Insurance often follows the same category, which can cut the cost roughly in half compared with a conventional car policy. Another line item where efficiency pays dividends. 3 wheels invite a different approach to balance and grip. Weight bias targets about 65% up front, placing the pack under and slightly forward of the seats to keep the nose planted. With motors at the wheels, the system can modulate torque with the speed and precision of a servo, responding quickly to slip, correcting understeer or oversteer before you perceive the slide. Regenerative braking benefits from the larger effective motor diameter, delivering strong one-pedal driving that harvests momentum and returns it to the battery. On low-speed maneuvers, precise independent control opens up possibilities usually reserved for robotics. Think tight pivots and playful spins in controlled environments, without compromising stability on real roads. The body panels don't rely on traditional paint. They're wrapped in durable films and vinyls, which do two clever things. First, they allow for quick surface refreshes and color changes without a paint booth. Second, they turn repair into a modular, replaceable operation. Wheel fairings, leading edges, and high-wear surfaces can be unlatched and swapped. The launch palette is restrained and elegant, silver gray, white, and a deep black wrap. And owners can customize trim with pre-cut film kits that cover key accents. Inside, sustainable materials like plant-based leathers pair with modular console pieces that can evolve with new accessories. The infotainment hardware keeps the display and computing unit separate, so upgrades can happen over time without redesigning the entire dash. In fact, the whole product strategy is about longevity. Solar panels are replaceable, battery modules are upgradable, and the software stack will evolve over the air. Daily life with this machine looks different because the friction is gone. Park outside while you work? The sun adds miles. Run errands across town? You likely don't plug in at all. Take a weekend trip 200 miles away to camp? Set up, enjoy the quiet, and let the battery creep upward each day. When you head home, you may have more energy than when you arrived. That's not a gadget trick. That's a consequence of an energy budget so small that ordinary sunlight matters. For power users, there's even room to expand. The solar charge controller is designed to accept additional accessory arrays for stationary use, bumping the wattage when your campsite needs to run a cooktop or keep laptops humming without tapping the main pack hard. And inside the cabin, a modest inverter can supply standard AC power for small devices, another gentle nudge away from generators and toward self-sufficiency. When the prototypes first met the public, thousands of reservations followed quickly, then tens of thousands, along with a sizable community of investors who wanted to see this category exist. Early interest naturally skewed toward engineers, pilots, and lifelong tinkerers, the people who look at the coefficient of drag the way art lovers look at brushstrokes. But the second wave is broader. Environmentally conscious families, commuters who'd rather spend on experiences than on energy, and anyone ready to embrace a design that doesn't apologize for being efficient. If you've ever wondered why cars all look the same, this is a different answer. The biggest impact might not be in driveways, it might be in fleet yards. Corporations and municipalities obsess over variable costs. A vehicle that consumes 1/4 the energy, that can be fed overnight on 110 volts, and that self-charges when parked, rewrites the operating spreadsheet. Rolling out hundreds or thousands of traditional EVs often means expensive charging infrastructure and massive power delivery upgrades. A fleet of ultra-efficient solar-assisted EVs partially sidesteps that bottleneck. Park them. Let the sun work. Add a lane of ordinary outlets for the occasional deeper top-off. The ESG boxes check themselves while the fuel bill collapses. When the industry converged on a sleeker, more compact charging standard, it wasn't by accident. It was a push toward better engineering and user experience. This vehicle embraced that push early. The design philosophy mirrors the rest of the car. Fewer parts, fewer steps, faster connections, less waiting. With an efficiency envelope this tight, charging becomes the smallest part of your ownership story. Not the central ritual that dictates your schedule. Is it really safe? Yes, because the structural strategy starts with a composite safety cell, abundant crush structure, and a focus on the human hip point inside impacts. Roof crush strength has tested at the top of the pack. Safety isn't a footnote, it's baked in. Can it replace my daily driver? If your daily distance is under a solar day's worth of miles, you may rarely plug in. If you travel farther, the pack options and fast charge capability are designed to keep road trips simple. Is there space for real life? Bikes fit. Camping gear fits. Groceries fit. The cargo length is about 7 feet with seats down, and the hatch design favors awkward objects instead of fighting them. What about cost? Efficiency cascades into affordability. A smaller pack can deliver big range when you only need $100 per mile. Insurance often lands lower due to regulatory classification. And sunlight is still free. Because the aerodynamic shape is already near the physical optimum, future improvements come from other fronts. Better cells slotted into the existing pack bay, more efficient in-wheel motors, updated solar panel chemistry, and software that learns. The core body will still be the right answer, which means the car you buy doesn't become obsolete because a curve changed slightly on next year's model. Long-term ownership stops feeling like a ticking clock and starts feeling like stewardship. Cold and hot weather validation continues across seasons and continents. Frozen test tracks in Central Europe. Heat-baked highways just a half-day's drive from the factory. Thermal management for the battery is engineered to keep the chemistry in its happy zone so winter mornings and summer afternoons don't surprise you. The plan is simple. No drama, just range you can count on. If you squint, you'll see echoes of gliders, sleek fish, and formula cars. That's not style for style's sake. It's physics showing through the skin. Rectangles have always been easy to package, which is why so many vehicles look like softened bricks. But the future won't be kind to wasted energy. As more people experience what it feels like to use less and get more, expectations change. Today, this looks futuristic. 20 years from now, it may look obvious. Here's the quiet part. No one notices on day one. A car this efficient changes your relationship with distance. You stop planning your week around charging. You stop worrying about whether the grid at your apartment can deliver level 2 power to every spot. You stop thinking about fuel altogether, because fuel is everywhere, falling from the sky, slipping across that low-drag body, sneaking into the pack mile by mile. So where does this leave you? It leaves you with a machine shaped by math, built like a protective cocoon, and wired like a minimalist's dream. It leaves you with a commute that costs almost nothing, and a weekend that powers itself. It leaves you with a sense that we don't have to choose between efficiency and desire, that the most radical thing a vehicle can do in 2025 is make you feel free. If you've ever wanted the future to show up early, this is what it looks like. A silhouette that cuts the air so cleanly the numbers feel unreal. A solar skin that turns light into motion, and a powertrain that wastes nothing. The question isn't whether this approach works. The question is how fast the world is willing to catch up. And that, more than anything, is the influence at play here. A movement sparked by the idea that efficiency can be beautiful, that less can be more, and that the best way to win the energy game is to stop playing by old rules.